Okay, the surface of a lens is coated with a film of magnesium fluoride, which has a refractive index of 1.38. The refractive index of the material of the lens is 1.67. Okay, calculate the three lowest value of the thickness of magnesium fluoride film. That would result in destructive interference for reflected light of wavelength 450 nanometer. Okay, so this is about thin film. Okay, so first of all, we need to identify this about question about thin film. Let me start it off. Okay, so this is about thin film questions. Yeah, and then we need to see there are two things here. One is the thin lens. Okay, one is a lens. Another thing is the film. Okay, another thing is the film. So he said the lens is coated with the film. Coated. See that? Coated. So we need to know which one is the middle layer and which one is the lower layer. So normally the coating, or we can say the coating is the thin film. The coating is the thin film, and the thin film should be the middle layer. It should be the middle layer, and then the lens is the lower layer. So we need to first be clear about this. Okay, let us draw these three layer first. Yeah, the upper layer, of course, is the air. Yeah, let us draw out these three layer of material. Yeah, so the lens is coated with the film, so we can say the lens should be at the bottom. The lens should be at the bottom. Okay, and then coating, so this should be the thin film, or we can say it is the coating. Yeah, coating, or we can say it is the magnesium fluoride. Right, magnesium fluoride. Okay, magnesium fluoride. Yeah. And then of course, and the air is the upper layer should be the air. Yeah? And then now list out the refractive index of each layer. So the lower layer is the lens. Yeah, lens is 1.67, and then the film or the coating or magnesium fluoride, that is the refractive index 1.38. Okay, and then the upper layer, the air, should be 1, n equal to 1. Okay, good. So now calculate the three lowest value of the thickness of magnesium fluoride film. So the important thing is actually the middle layer. Important thing is the middle layer. Yeah, so the important thing should be the middle layer. The film. Okay. So three lowest value of the thickness of magnesium fluoride film, that will result in the destructive interference. Okay, so also look for this keyword about destructive interference. So destructive interference means it form dark fringe. Look for these keywords. Yeah, destructive interference means dark fringe, form dark fringe. And then you got reflected light of wavelength. I give you the wavelength here. Okay, I need three lowest value of thickness. So I need the need to find the thickness. Thickness, but thickness, the lowest value. The lowest mid value. This thickness should be the lowest value. Three lowest value. Okay, so first of all, we need to know what type of film is this. Okay, should we get two in phase source or two anti-phase source? That is very important. Is this reflective coating or non-reflective coating? So So that's why we need to draw out this structure first. Then we draw the ray. And then we can see whether it is two in-phase source or two anti-phase source. Okay, so this one, the ray, there's a ray coming, and then one light reflected, another light go into the source. Okay, go into the source, and then go through the thin film, and then this one also reflected out. Okay, so you have so here you have ray 1 and ray 2. Okay, here you have ray 1 and ray 2. Let me rearrange this thing. So you have ray 1 and ray 2. Now look at ray 1. Is there any phase change? Remember our notes? Look back to our notes. Phase change only happens when reflection from lower to higher refractive index. That means, for example, like you see this one, phase change only happen when the ray go from lower refractive index to higher refractive index. Got phase change of pi radian. Okay. So this one is, the first ray is reflection from lower to higher refractive index. So got phase change of pi radian. Here got a phase change of pi radian. So so ray 1 got pi radian phase change. And then about ray 2? Ray 2 is you see the ray go into reflection no phase change, and then at this surface also reflection from lower to higher refractive index, reflection. So this one also got phase change, of pi radian. Understand? So first ray is reflection from lower to higher refractive index, got phase change, and then the second ray also from lower to higher refractive index, also got phase change. We can write this at the beside there. Okay, so we can say this is like low refractive index, higher, and then highest. This one is considered like low, higher, highest refractive index. So each ray also got pi radian phase change. So what is the delta phi? Delta phi, since both ray got phase change, so what's the delta phi? So delta phi is pi minus pi radian, 0 radian of phase difference between the two ray. So these two ray has no phase difference, they are in phase. Okay, because pi minus pi becomes 0, so it becomes in phase. So this is about this one, two sources in phase. Okay, it's like from low, higher, highest. So both ray also got phase change, because for both ray, ray 1 got is a reflection from lower to higher refractive index. Second ray also from lower to higher refractive index reflection. So both ray also got pi radian phase change. So we can say pi minus pi becomes 0. That means both sources of light, ray 1 and ray 2, they are in phase. Okay, so these both ray, they have pi radian phase change. So that means there's no phase difference between them. So these two ray are in phase. So this is about two in phase sources. Okay, this is about two in phase sources. So when talking about two in phase sources, very simple. Go back to our notes. Two in phase sources. When two sources in phase, the delta L is m lambda, and then for bright fringe, the delta is m lambda. If dark fringe, the delta L is m plus half lambda. So two in phase sources, the bright fringe delta L is m lambda, the dark fringe delta L is m plus half lambda. Understand? So you see that? Go to your notes, this one. See that? Two sources in phase. So in phase, the bright fringe one is using m lambda. Dark fringe is using m plus half lambda. Okay? In phase source. So that's remember that one. Okay? So for two in phase sources, the bright fringe formula use 2nt 2nt equal to m lambda. Dark fringe 2nt equal to m plus half lambda. Okay, so in phase source, bright fringe use m lambda, dark fringe use m plus half lambda. Yeah, like what I say about this one. Look at where is it? Yeah, this one. Yeah, if two in phase sources, bright fringe use m lambda, dark fringe use m plus half lambda. If anti-phase, then they interchange. If anti-phase, then the bright fringe is m plus half lambda, dark fringe is m lambda. Understand? Now in phase source, bright fringe use m lambda, dark fringe use m plus half lambda. Okay? Two in phase source, bright fringe use m lambda, dark fringe use m plus half lambda. Okay. And then go back to thin film. Go back to thin film. So the order also start from 0. Yeah, order also start from 0. I want you to write that down also. Order start from 0. 0, 1, 2, 3, and so on. Okay. And then I want the 3 lowest value of dark fringe. 3 lowest value of dark fringe. So I need to use the dark fringe formula. Okay, because it's destructive interference. Destructive interference use dark fringe formula. So use this one. Use this one. Understand? Use this one. So okay, let us continue. Let us continue. So question A, yeah? Question A. So we use the dark destructive interference. So it's a dark fringe formula. So we're going to use the 2nt equal to m plus half lambda. And then this one, since you want the lowest value of thickness, yeah, you want the lowest value of thickness. That means when the thickness is the lowest, that means the order also lowest. Order also lowest. But what is the minimum value of order? Yeah, minimum value of order. So be careful. Since we are using dark fringe, so our minimum order can go to 0. Yeah, start from 0. But if you use bright fringe, the minimum order is 1, not 0. This minimum order need to be 1 because the thickness, if you put m equal to 0 for bright fringe, if you use m equal to 0, then the thickness becomes 0, which you are saying that the thin film thickness is 0 thickness, which is impossible. Understand? So for bright fringe, the order start from 1. But for dark fringe, the order start from 0. Okay, the order start from 0 because it got a half lambda there. Because it got you know, there is a half lambda here. So even you put the order equal to, even you put the m equal to 0, the thickness is still not 0 because got half lambda. So since you want the lowest thickness, means your order need to be lowest also. So the order can start from 0. No need to start from 1. Okay, so that means the order, that means this one, it means that this, let me write it. So lowest, that means I need the lowest one. The lowest one, that means is 0 and 1 and 2 lah. These 3 value lah. The 3 values, 3 lowest m for dark fringe. Understand? That's a 3 lowest order value for dark fringe. So it's 0, 1, 2 lah. Okay. Alright. So now let's use this formula and substitute m with 0 and 1 and 2. Okay. And then we can find. And then the order, the n need to use the Flum one. Be careful. The n value. The n value here. The n value here. This n value is n of Flum. N of Flum. N of Flum or n of coating. Or n of the magnesium fluoride. Understand? Which is 1.38. Don't use the wrong one. Don't use 1.67 lens. Don't use. Because lens is not the thin film. Lens is not the coating. The lens is coated by magnesium fluoride. Yeah, it's coated by magnesium fluoride. Magnesium fluoride should be the coating. So this n is the n for film, not n for lens. Remember that. Okay. So I want to find the T value, and then I substitute with 3 lowest order. Okay. For half, if the equation, since the equation has half lambda, that means the order can go to 0. It can go to 0. Yeah, it can go to 0. If the equation don't have half lambda, just m lambda. If just m lambda, then it cannot go to, the order cannot go to 0. The order need to start from 1. Understand? That is for bright fringe lah. The bright fringe m lambda need to start from 1. But for dark fringe, because got half lambda, the order can go to 0. Because the thickness is still not 0. Because the thickness is still not 0. Since even the order is 0, because it still got half lambda for the thickness. Understand? Okay. Now, okay, lambda is, what is the value of lambda? Lambda is 450 nanometer. Okay, so I have everything needed. So I just substitute the value. Okay, substitute the value, and I can get the answer. So 2. So I start with m equal to 0. Okay, I start from m equal to 0. So 2n 1.38 multiplied by thickness, and then this one is 0 plus half lambda. What is the lambda? So lambda is 450 nanometer. Nanometer is -9 meter. Yeah, change to SI unit, and then find the thickness. Let's find out. Yeah, so 2 times 1.38, and then okay, that's and then 450 exponent -9 multiply by this 0 plus half, which is half lah, 2.5 divided by this answer. So I got the first thickness is 8.15 exponent -8 meter. That's the first answer. Okay, and then the second answer, I substitute the order with equal to, I substitute the order equal to 1, m equal to 1. And this is what we call order. M is what we call order. Yeah, m is called the order. So the order you can substitute with 0, 1, 2, 3 lowest value, 3 lowest order m for dark fringe. Okay. The second one, I substitute with 1. Okay, and then the rest is the same value. Okay, and then the third lowest thickness is I substitute the order with 2. Yeah, I substitute the order with 2, and then okay, let's check out. Yeah, let's check out the answer. So 450 exponent -9 multiplied by 1 plus half, and then divide by 2 divided by 1.38. So the answer is 2.45 exponent -7 meter. That's the thickness. And then the next one, this one is put in this one is order 2. Okay, order 2, okay, and then the answer will be, the thickness will become 4.07, no, 4.08 exponent 4.08 exponent 08 exponent -7 meter. So that's the answer. The three lowest thickness. These are the three lowest thickness for three lowest order M for dark fringe. Okay, so is the answer correct? Let me check the answer. So the first one is 8.15 exponent -8. That's correct, meter. And then the second one, 2.45 exponent -7 meter. That's correct also. And then 4.08 exponent -7 meter. 4.08 exponent -7 meter. That's correct also. And then okay, the answer all correct. Now what's the okay, so now if the thickness of the film is the second lowest value calculated in A before, for what wavelength of the light reflected from the lens will constructive interference occur? Okay, so now question B is saying that let's look carefully. Yeah, question B is say the thickness film is the second lowest value calculated in the question A. Okay, what is the second lowest value for thickness? Second lowest value. So this one is the lowest value. Okay, when zero order is the lowest, then this one is the lowest. So this one is the highest, this one is the second lah. So look for this one. Yeah, this is the second lowest. This is the second lowest thickness. Okay, second lowest thickness, 2.45 exponent -7. Okay, this one is the lowest value because exponent -8. Others is just -7. Okay, this one is -8. This one is the lowest value. Okay, second lowest is 2.45 exponent -7. So we're going to use this value. For question B. Yeah, we're going to use it for question B. So now for what wavelength? So he asked for what is the wavelength, a new wavelength. Yeah, just put lambda 2 of light reflected from the lens will be constructive interference occur. Constructive interference. So forming bright fringe. So okay, we want to find bright fringe. Bright constructive interference. That means bright fringe. So okay, we're going to use the bright fringe formula. So let's do for question. Let's do question B using the bright fringe formula. Which is because it's 2 in phase source. 2 in phase source. So the bright fringe is using m lambda. Okay, so 2nt equal to m lambda. Okay, now the thickness is the second lowest value, which is this one. Okay, just transfer this value, 2.45 exponent -7 meter. So thickness here is 2.45 exponent -7. Yeah, the second lowest value just now, 2.45 exponent -7. 2.45 exponent -7 meter. Okay, I got the thickness. The n is still the same. The n is still 1.38, the film one. Okay, the N is still the N of film or magnesium fluoride, which is 1.38. Okay, and thickness I got. So okay, for what wavelength? Second lowest value. For what wavelength will the constructive interference occur? So what's the order I should put here? What's the order I should put here? Okay, I think what's the order I should put here? So okay, by default this one should be order 1 lah. Yeah, put order 1. Yeah, same with this one. Yeah, order 1. This one you just put order 1. Okay, order 1, because why? The order start from 1 for bright fringe. The thickness cannot be 0. The thickness cannot be 0, so M cannot equal to 0. Yeah, this one, the M cannot equal to 0. Because what? Because the thickness cannot be 0. Understand? The thickness cannot be 0. If M equal to 0, the thickness of the film becomes 0. If M equal to 0, then the thickness of the film becomes 0. That means there's the thickness of the film is 0 thickness. Like there is no film, there is no thin film, which is impossible. So M cannot be 0. So M must be equal to. So for this one, M equal to 1. M equal to 1. That's the minimum for bright fringe. Yeah, there's a minimum order for bright fringe. So I just put M equal to 1, and I can find the answer. N 1.38, thickness 2.45 exponent -7, and then order is equal to 1, and lambda. Yeah, I want to find the lambda. This is considered lambda 2. So what is the lambda? Let's calculate. 2x times 1.38 apply 2.45 exponent -7, and yeah, that's it, the answer. So the answer is 6.76 exponent -7 meter. Is that an answer correct? So I can also change it to 676 exponent -9 meter. Yeah, -9 meter. So this is actually 676 nanometer. So is the answer correct? Yes, answer is 676 nanometer. That's correct. Okay, that's correct. 676 nanometer. Okay, so that's it. Yeah. Yeah, this order also follow the order here lah. Okay, because it say thickness, use the second lowest value. What's the wavelength of the light reflected with constructive interference occur? So the order cannot be 0. It must be start from 1. Yeah, the thickness cannot be 0, start from 1. Okay, so that's all for this question. I hope you understand. Bye.